Study.
Hello guys, welcome back to Study Buddies. So the lesson of the day is linear momentum. In this lesson, we will learn about part 1 of linear momentum, which is about impulse and momentum. Let's start off with impulsive force. Impulsive force is the rate of change in momentum. From the definition itself, I'm sure some of y'all already have idea of what would its formula be. Yes, you guys are right. The formula of impulsive force is F equals to mv minus mu over t, where m is the mass of the object, v is final velocity of the object, u is initial velocity of the object, and t is time of impact. As we know, impulsive force is dependent to change in momentum and time of impact. So by changing these two factors, we can actually reduce or increase the impact of an object. The impact of an object decreases when the change in momentum decreases and the time of impact increases. As for higher impact, it is vice versa. The example of application of impulsive force in our daily life are high jump and airbag in car. So you might be wondering, why don't the athletes get hurt when they land on the mattresses during high jump? When the athletes land on the mattresses will eventually increase time of impact and hence reduces the impulsive force acting on the high jumper. Moving on to impulse. Impulse can be defined as change in momentum. So why do we define so? Do you guys still remember Newton's second law of motion's equation, which is F equals to P over T? Alright, when you bring up the T to the other side of the equation, you will get Ft equals to change in momentum. This equation is also equals to I, as I is the symbol of impulse. For your information, change in momentum is also equals to mv minus mu. The SI unit of impulse is Newton's second. For a better understanding, let's look at a sample question. A tennis ball is struck by a racket with a force of 3600 Newton for a duration of 0.03 seconds. What is the change in momentum of the tennis ball? Okay, this is a direct question, so all you have to do is apply the formula. Change in momentum is equals to Ft. Substitute the values into the equation and solve it. And with that, you will get change in momentum is equals to 108 Newton second. Don't forget to write the SI unit at the end of your working. Proceeding with the next example. A 1 kg ball is coming straight at a 65 kg soccer player at 12 meter per second who kicks it in the opposite direction at 20 meter per second with an average force of 1500 Newton. How long are the ball and his foot in contact? Alright, for previous question, it was a direct question as they asked us to calculate the impulse. But for this question, you have to be careful because they are asking us to find the time and not impulse. To make it easier, list down all the given information at the side. Remember, since we are talking about impulse of the ball, we use mass of the ball and not the player's mass. Based on the given information, the suitable formula to be used for this question is impulse formula, which is Ft equals to change in momentum. Since we want to find the time, bring the F to the right side of your equation. Now, substitute the given values and solve it. When you solve the equation, you will get T equals to 0.0213 second. Next, we will learn about force time graph. We can actually use this graph to find impulse. All you have to do is find the area under the graph. The area under the graph is equals to impulse. So how do we calculate the area under the graph? Alright, if your graph has a geometric shape like a triangle, square, or a trapezium, then we can use the formula of each shape to find its area. But then if the graph is in some random shape, then we can perform integration in order to find the area under the graph. To make you all understand this better, let's look at a sample question. An object with mass m equals to 4.0 kg experiences a force in Newton according to the force versus time graph below. For the time interval shown, what is the total change in momentum of the object? Alright, for this question, they want us to find total change in momentum, which is impulse of the object. As I said just now, impulse is equals to the area under the graph. So you might be wondering, what shape is this and how do we calculate the area under the graph? No worries, we can break this into two different shapes, which are into a triangle and a trapezium. Let's calculate the area of triangle first, followed by the area of trapezium. Once you have calculated both the areas, plus them together as we want to find the total area under the graph. The addition of both the areas will give us a total of 11 Newton second, which means the total change in momentum of the object is 11 Newton second. So that is all for today. We will end today's lesson here. Thank you for watching, guys. If you have any question regarding this lesson, feel free to comment in the comment section below. Don't forget to like, subscribe, and hit the bell button down there. See you all in the next video. Bye!